mostly drag and drop components for the programming side, and then there's a screen editor that allows you to create the screens. It's very cool being able to create these apps. I think Android phones are a pretty good thing for any robot because they're as powerful as a laptop computer. They have total communications with the earth, and GPS. It's all built in. I mean, you don't have to buy anything. It's already there. One of the things that Beer 2 can do is he can play pretty much any audio file that's on the internet. So he has an unlimited vocabulary and sound effects and music and movies. And, one thing I thought about adding would be kind of cool would be a video projector. I might do that. They can actually play movies on the wall somewhere. Continuing on with that, Beer 2 D2 was built, like I said, with that Heineken keg, and he also has his wheel pantser from the Martha Stewart collection that used to be at Kmart. I think that adds a little bit of class. And his head is a mixing bowl that I found at a Goodwill. He's basically made out of obtainium. My friend Camp Peavy and I kind of believe in obtainium. You can build a robot out of just about anything, and many of us have. Now, one of the new additions to him is he has a new cool trailer that a friend of mine actually built for me. This is actually made out of some kind of resin, and he cast it. It's amazing. Plus, it's also got cut out parts that he did with a laser. And these castings are actually from files from actual Star Wars, from Industrial Lights and Magic. So there's some real stuff there. Anyways, and then the other thing that I've done is I've created this Android app. This is just one of several that I've actually created. I don't know how well you can see that, but it has speech recognition. It has text-to-speech. Has multiple buttons to trigger different things, sound effects, and to turn things on and off. You can control quite a few things. Like his bubbles, you can turn them on. You can also do different audio effects.
Betcha, it's the all-new Johnny 5. Just look at these items. Increased memory, 500 megabytes online. I come with a utility pack, dozens of gadgets for outdoor living, lots of green pea stickers, and even my own Nike swoosh. And if you act now, I'll throw in absolutely free my all-new multi-frequency remote control. I can't help it. I'm in a panic. I'm frantic.
Anyways, so he's also a lot of fun, and I can put the bubbles on there because I like playing with the kids at different events. You know, the little children, they follow him around. He's not big and he doesn't threaten them. Technically, this is a very complicated machine. It seems very simple, but I can guarantee you there is a lot of stuff inside of this can. When you get into doing a whole bunch of sensors, multiple Arduinos, audio, a mixer board, multiple power supplies. Fills the can up pretty good. Really good. Not sure how many things I can add to him at this point after this, although I want him to get his own camera. I've been using this Husky Lens camera, but I want to actually mount an Android phone onto him and use its cameras for doing facial recognition and navigation, because I just learned how to do that with App Inventor, and I'm pretty excited about that. That's really cool, and it's actually very similar to OpenCV, that some of the things you can do with App Inventor and an extension to it. So I'm getting into that. I also have it working GPS. It'll do GPS coordinates and display a map on the Android phone with a red dot where it's at. It's just like Google Maps does in your car. So it'll do that too. I also did a couple tests with GPT-4, and I got it so I can talk to it with my voice, and then it sends a text string to ChatGPT, and then it comes back, and then it reads that back as speech to text, and so you have a two-way conversation vocally with a computer, which is pretty cool considering that it's always been in sci-fi, but it's never been in reality until just recently.
All right, Steve, that's your 5 minutes. That's Beer 2 D2's 5 minutes.
Okay, you know me, I could go on for days.
I know, we're going to slow you down. Thank you very much, Steve.
All right, buddy, you have a good one.
Very nice. Beer 2 D2, ladies and gentlemen.
Camp, can you hear me?
Yes.
So we have one here that's because of battery considerations, they would like to go next.
Very fine.
So if you switch
In
over to
orbit.
here,
It's yours.
can you highlight the
that the
HBRC
right-
cam?
Right one, yeah.
This is Frank the Tank.
Can you hear Steve okay?
It's got a
Steve, introduce yourself and introduce your robot.
Sorry?
Introduce yourself and introduce your
Sure.
robot.
Okay, I'm Steve Joyce. I've been coming the last year or so, and before that, I was coming about 10, 12 years ago for quite a while. The robot, Frank the Tank, originally I was going to call it Frankenstein because I was pulling out parts from my old robot and putting new parts in, and so I just shortened it to Frank the Tank. So in terms of features,
What are you calling it, Steve?
pardon me, Frank the Tank.
Frank the Tank.
Frank the Tank.
I like it.
And previously, last time I was here for phase one, it was running on an Arduino in a 293 motor driver, upgraded to Raspberry Pi so I can do some of the vision stuff, as well as the 6612 CMOS motor driver is more efficient. So it's upgraded. Also, I've got this little LED so I can get status of it. And it says as to what the status is as it's moving. So then I can get really quick when it does something wrong. I can get some raw data really quick. Okay. This is the big stuff. I have a couple of pings that aren't active for today. I'm doing this solely on the vision, which been successful for me.
We'll find out about that.
Yeah. I was about 8 out of 10 yesterday. See what we get. Okay. Now this runs, as you would expect, autonomously. All I need to do is press a button and do this. Takes about. Okay, it says it's out of the loop. Oh, I'm going to put power on too. It's always good. Okay, so power's on. Takes about 20 seconds or so to get started. Okay, it's on. It's all right, just a bit. My long move forward. And there's no, yeah, typically if there's a ridge, a little bit of problem because it gets turned, but that's might be a problem.
The chat is asking Frank the Tank appears to be a paralyzed stingray.
Is it what?
Is it a paralyzed stingray?
It used to be before I got it. And going from Parallax to Arduino is a reasonable jump. And going from Arduino to Raspberry Pi is it is
That
not being
green
helpful.
block was a mouse. I don't think it would be catching it.
Yeah. Yeah, it's having trouble with this.
Steve, are those popsicle sticks? Steve, are those popsicle sticks?
Pardon me?
Are those popsicle sticks?
Oh, pops, no, it's balsa wood. I sometimes
Balsa-
use balsa. Because you
Balsa
can-
wood?
Yeah, balsa wood, because you can, change it on the fly, right?
All right,
Okay,
you're my
so
hero.
now it's identified that, it's in the hook, I call it the hook, and it'll rotate just a little bit. And hopefully point towards the edge of the table. Now, what this was designed to do is when the cube falls off, it stops. So we'll see how that goes too.
What are you using at the edge of the table? Is it,
It's
open CV?
actually, it's the cube falling off detects the, I'm not detecting the end of the.
No, but to align itself to the.
What it does is, first it looks for it, and then it says, okay, it's there. And then after, since it had to go to the right, it says, okay, I have to go to the right more. So then it captures it, has it in the hook, and then moves to the right more, and then goes forward. And it looks like one or two more pushes. All right. Now let's see.
Phase two.
Stop. Okay, it's saying 0, 0.
Frank
So that
Tank
means-
got phase two.
that is phase 2. Thank you.
That was a fantastic demo.
Thank you. Thank you very much.
Any questions for Steve?
Yeah. Any questions?
I see it has quite grippy wheels. Pardon? It has quite grippy wheels, right?
Yeah.
But it still had trouble with the ridge.
Yeah.
Yeah,
but
because of weight.
Um,
It's too much.
I think it's because I didn't, I put the motor on for a short duration because I was more concerned about running off the table.
I see.
And at home, it will we'll go over the hump and then keep going. This is the first time it's stopped. So if I were doing this on a regular basis, I think I did it 30% duty cycle. I would go to 40. Just to be sure of that.
Does the chassis have motors on the motors, so you can do like PID control?
Down.
Yeah, you put motors on the.
Actually, previously it came to, one of the motors died, so I replaced it. The other one still has it, but I didn't need to do it to get it to work.
So, I get run off the table, but I can speed up, I run off the table, is it the sensor, latency reading?
We can't hear the discussion online.
Right there, what it did was, I have OpenCV, and I'm looking for color. And what it does is it looks for green, and when it sees green, it goes towards it. And when there's nothing that's green, like when it falls off the table, it says stop. Yeah. I was light on the motors, and believe it or not, that was a fast speed. That was level 4 out of 4. Typically it's coming in at about, I've timed it, it was about 2.5 minutes to finish. Yeah, well, I started out at 8 minutes, and yeah, I got done in 2.5. And I felt that people's attention span was probably 3 minutes before I started getting booed. So I said, I got to get between 2 and 3 minutes. Pardon me? Yeah. So yeah, I could have analyzed it further. Really, I only got it debugged to a point I was happy with. It's about a week ago. So, you know. So yeah.
Thank you very much, Steve.
It's rare that a demo works first time.
Ah.
Well done.
Okay, thank you.
Well done.
Thank you,
Okay,
Steve.
Camp,
Frank the Tank.
Yes.
Frank the Tank.
we have at least 3 more here, Camp. Do you want to
Yeah,
go
go ahead.
to? Do you want to go here? Okay, who wants to go next? Who's ready?
I need to. So.
You ready? Nathan and then, okay.
Nathan Lewis, ladies and gentlemen.
Alrighty, so. Alrighty, so I have just, it's a little line follower that I put together earlier this year. I got a new 3D printer over the holidays. I kind of decided that I wanted to do an entirely end-to-end 3D printed project, except for say a few mechanical components like motors and bearings. So I it's probably, or sorry, so I did a custom PCB with KeyCAD and JLC PCB. There's basically just 16 line sensors across the bottom. There's 14 clustered in the center. There's one on each end, or one on the far side of each end and 14 clustered in the center. They're spaced so that with your standard 0.75 inch electrical tape, you get 4 sensors on the line at any given time. So the goal was I was trying to design it for the NACCAR challenge at RoboGames, but I didn't have the time to finish it. So I know it's challenging about the news. I'm supposed to bring a table lot, but I was on vacation most of the month, so I just was messing around. I got back yesterday, so just trying to program it today. And basically, I've got a simple little demo. We'll go around and then it's supposed to stop at the end. This is I tried to follow the NACCAR course rules. It's mostly compliant. It's just small. Alright, so just start with here. And first step is I just calibrate on line. Wow. Meander. So at this point, I don't have a full pit loop working yet. So even though there are 14 sensors along the bottom, it's just doing your classic 2 sensor ping pong back and forth. Don't have the power turned up all that much. I've been so ideally I want to do something fast. So there's an IMU on board. I just don't have it working yet. So I don't really actually know how fast I'm going at any given point. It's mostly just fast enough, hopefully fast enough not to stop, but just fast enough to actually move.
What are you doing with the white markers?
Okay, so with NACCAR, essentially what they do, and it stops at the end. So what the little markers are is, so with NACCAR, you get 3 runs, kind of like Road Magellan, and the idea is, as fast as sun wins. But what they do is that at the beginning and the end of the course are marked with a white stripe on the right-hand side of the course, or right-hand side of the line. And so you're supposed to kind of start it in the center here, and then your time officially starts being measured as you pass the first tick mark on the right-hand side. And then anytime there is a change in the course, they put a tick mark on the left. So the idea is that you're guaranteed that either the curve or the curve is the same radius, or you're going in a straight line at any given tick mark. And anytime the course is going to change, they place one. So the idea is that anytime you see it, you basically mark it, see what you did since the last tick mark, and that lets you remember what the course is like. So as you're entering a turn, you can just immediately start performing whatever turn you're supposed to do, or go straight, because the goal is to try to do it at high speed. Right now, I'm not doing anything with them, but they're there because they're supposed to be part of the course. So eventually the goal, so this is technically my phase 1. My phase 2 would be actually remember the course and try to go fast. And then a phase 3 would be try to do a line maze rather than just a standard line follower course. Again, the only real maybe interesting design aspect of the little robot is that the line sensors are placed exactly half the wheelbase in front of the wheels. Because what that lets you do is if you basically lock one motor and you do a 90-degree turn with the other one, if you have come to an intersection on a line maze, will be exactly aligned with the next line on the turn. That's it.
Any questions in the room? Any questions online?
Yes.
That's very cool, Nathan.
Hang on, we have a question.
Are the wheels 3D printed as well?
Wheels are not 3D printed. The Pololu 20, I think these are the N25 gear motors, the little teeny ones. So they're just a stock off-the-shelf part. Basically the non-3D printed parts are the wheels, the motors. Well, I mean the motors obviously 3D printed, but it's the wheels, and then there's a couple of bearings for parts of the caster. Other than that, everything's 3D printed. Yes.
Where do you buy curved electrical tape?
You stretch it in a curve. So you stick one side and you slowly try to stretch it on one side to make the turn. So there's no curved electrical. You can see me messing up right here.
That might be the hardest. That might be the hardest technology to make.
So basically, I sat there. The way that I did it was occasionally, if you look at the course, you can see a couple little pencil tick marks. basically I took a piece of string and a pencil and would like draw the curves, and then I would try to stretch the electrical tape like along the line. So I think I spent more time trying to put the course together than writing code for it. So it's like I'm doing a robot project. Why am I walking out with Michaels?
Any more questions?
Thank you, Nathan.
Did you want to go next?
Ready.
Let him go, okay. Dillo is ready. I think he's coming after me.
No, 6-wheel drive.
Okay, so now.
Dillo, okay.
Can you introduce yourself to those few people that don't know you?
Oh, hi, I'm Steve Gillow, okay, I've been a club member for a really long
Ever.
time. I built, well, I'm also a total Ross bag, yeah, I built this 3D printed robot. This is a Sophie build. So it's a almost entirely 3D printed, mostly PTG. There's some PLA, and then the wheels are a carbon fiber nylon. It's like a quarter scale of the actual Curiosity rover, and it has a lot of features. So it has the corner steering. And it has the rocker bogie. I'll just whoop. I'm gonna put it up on the table here, just so that people can get a better view. So that you get on it, show off. Yeah, so this is the latest iteration. I've been working on this for a few years. Most recent is I have a proper pan tilt mount, pan tilt here. The servos that I'm using, they're all Dynamixels. This is an OD light camera. I did the CAD for this holder and the neck and the mast. So it was like, doesn't turn completely to the right yet. To the left, I'm trying to figure that out. I think like the start point is a little bit offset. I haven't figured out exactly what the proper offset is. So it pans and then tilts. And this is an OD, and it's hooked into a Raspberry Pi 4. I have blinky LED because people like blinky LEDs. That's like a simple on sign. It's a I'm using using the IBOS protocol on a standard RC because I got away from I had a USB like a PS4 not PS3 joystick knockoff for a long time, and I just had a lot of problems with interruptions, losing the link with that. And this actually works like from all the way back here. Like it'll work.
Cool.
Here. So on the back here, you come around on the back. This is kind of cool. I have some debug ports here. So I have a USB that goes right into the Arduino for the motor controller. So when I want to push motor controller updates, I just attach a USB cable there. For more serious debugging, Ethernet, and then also HDMI right into the Pi. So, you can ask me why I did this. Why did I do? Because I have had to, over the course of the development of this thing, take it apart and dig in and pull out wires and things like that, because, you know, something wasn't quite right. And so I actually needed to get onto the Pi. So, that came loose. So yeah, I added those on there. Let's see here. What else? Batteries, that, and then I'm going to try something kind of dangerous here. Which is the robot is robot is going to attempt phase 1, because what do I have in here up here? That is a cliff sensor. And that cliff sensor is wired right into the motor control loop. And I've got a video of this. I tested it. So if hopefully it will actually see the table disappear from under it and just plain refuse to move.
I'm not gonna let the thing fall on my feet.
Yeah, and not.
Want to make a bid right now?
Yeah.
Falls off.
Okay, and now I'm moving the joystick and I can't drive it because, the cliff sensor is showing like 1 point. Oh, shit. It will go backwards.
There you
though.
go. I was waiting for that.
Okay.
That was a good catch.
Cliff sensor in the back. Thank you, okay, and I didn't know, I have safety. Here's the other thing, I have safety on the joystick. So you notice that the blue LED is off. This cuts out, which is also wires right into motor control. I have safety off and they.
Steve, I'm blanking. What is your robot's name?
Tenacity.
Tenacity, that's it.
Tenacity was one of the finalist names for what became Perseverance. When Perseverance was still called Mars 2020, and they had some on a name for it. One of the names on the short list were of course Perseverance, and then Tenacity and Temerity and Audacity. And I liked the name. I like Tenacity because really to get a robot to this phase, to the stage, you have to be tenacious to develop any robot. You have to have a certain level of tenaciousness or tenacity. And then like the tagline, I made a bunch of stickers inspired by one of the Curiosity bumper stickers. NASA was selling these bumper stickers for a while that had a picture of Curiosity on it. It says, "Curiosity drives us forward." And I'm like, okay, so I have stickers that say, "And tenacity sees you through." So curiosity is the inspiration, but tenacity is actually you need to get. And so that's it. I'm going to drive it around here. There's a bunch of other features that I haven't talked about, like there is a Depth AI on here. I do have some scripts that use a YOLO-based model to follow the outline of the person. So I've re-implemented the old Turtlebot follower in a much more much more accurate and much more resilient form, where it's not just looking at what outlines are your legs with a LiDAR. It's actually looking for the full outline of a person, and it will ignore half out. We've already tested this. It will ignore half outlines and legs and other body. It needs to. So, like if you're in a crowd, the effect of this is if you're in a crowd and it's following you, it ignores everybody else walking by, even people that walk in front.
Wow.
So let's get this off of the table.
All right, I think we've got a stack up of people coming, so
Okay.
we can.
Oh, you're gonna leave it on there? I can just I put
No, I think we need to move to the next one.
Oh, okay, yeah, all right. Well, let me get this on the table then. Yeah, I thought about that. I actually did. Before I had the little cabin on there, before I had the little battery cabin on there, these here were handles. And I had some handles that you clip on to lift it. But yeah, I think maybe I don't know what kind of drone will lift this up. It weighs about 20 pounds.
Really big drone.
It's not a small robot. So yeah, okay. So yeah, you see the come on. And oh, I think it's detecting something. All right, well, let's go robot. And thank you.
Great, awesome robot.
Tenacity. And Steve OK, aka Dillo. Hey, Rohan.
Hey.
You want to introduce yourself to
Yeah.
the few people that donate?
Yeah, so I'm Rohan, and this is my robot Tumbly. I showed this doing phase one and whatever the phase one demos were. And I'm gonna show it doing phase one again. It's slightly different this time, I promise. I
Rohan,
don't
what's your
know.
robot's name again?
Tumbly,
Tumbly.
because the first thing it did was pass phase four. Yeah, so this time the Pi is not just ballast, it is actually running ROS. Okay. Which is why I don't trust it anymore. But actually I was trying to get it to run micro ROS and like get the whole stack communicating with each other properly, but I got distracted by figuring out Wi-Fi problems instead. So this is still running the same firmware as last time. The Pi is just running the ROS.
That was close.
A little bit more than just being ballast this time, but just thought I would show the phase one again.
Yeehaw.
Your 180-degree turns are very accurate. You use odometry?
Yeah. So I have odometry on there. I also have it calibrated, aka the slight differences in the wheel thing I just corrected for in software. So yeah, and if you notice, it's slowing down before the edge because I'm using one of these ST time of flight cameras. Didn't quite slow down enough, but yeah. It's using the ST time of flight cameras to detect the edge before it gets there so it can slow down before the edge. And then it's using these two to stop at the edge. And yeah, so
That's awesome.
that's
Very good. Tumblr. And
Question,
Rohan,
wait,
very good.
I have a question. What is the time of flight camera? What does that do?
First question in the room. This is the Pololu Romy chassis. Yeah. Yeah. So it's a Romy chassis, but instead of using the 6 AA's, I have two 18650s on the top. Because that's just way easier. What was the question online?
I was asking about time of flight camera. What does that do? How does it determine, the distance to stop?
So this is one of ST's time of flight cameras. It has a laser that sends out a pulse of light, and then it has an 8x8 grid of receivers. So you get 64 pixels of a depth image. Not very many pixels, but you do get a bit of a depth image. So then you can figure out which row of pixels is the first one that has a large distance instead of a small distance, and then do a little bit of trig to figure out how far away that is.
Kind of like they used to have for the Kinect.
Yeah, it's similar to the Kinect, except it's like $6.
Does it work outside in the sun?
No,
Okay.
not at all. It also doesn't work on glass tables. So on glass tables, it's always on the go slow mode. So that's also fun.
Any more questions? Online in the room or online?
Take it, Rohan.
Thank you. Great. I'm going to set the camera down. Take it away, Cam.
Okay. Jim D'Annunzio, you're up next.
All right, thank you. So I've been working on my Truckosaurus robot, which is a RC car crawler truck. Let's see. How do you focus?
Very pretty.
Oh,
Jim, are you sharing your screen or are we trying to look at your camera?
let's do the camera first here. So I have a. Oh, hold on a sec. Okay. Yeah, so here's This is Truckosaurus, and Truckosaurus is a RC crawler. And so I'm Jim D'Annunzio. I'm a software engineer for many years, worked for Samsung. And so Truckosaurus is an RC car modified to go in Robo Magellan, and has also indoor use for navigating around the house as a test case, but it's mainly an outdoor robot. So today I'm just going to demo Floorbot Challenge Phase 1 using this LiDAR and mapping and everything. Truckosaurus has an Oak D light camera as well in front, which is going to be used to find the cone. And it's got a front bumper for those unintended collisions. And in the back, it has a GPS antenna in the black. And the LiDAR on top is called a SlamTech M1 Mapper, which is now discontinued product, but very but I brought it back to life with a ROS 2 driver implementation, which is available, and it publishes its own topics right in ROS 2 for the not just the laser, but also a map and the pose of the robot. So it does a lot of stuff built into the hardware there. And I'm going to eventually use this camera to show it moving, but now I'm going to I'll share the screen here. So you should be able to see my Linux desktop, and I'll briefly just show you the map and RViz and everything. Then I'm going to close this. So this is the room here. I'm going to have them go down the end of the room and come back. I've written a script where I can have it capture points. And so I run the script and I can use this 2D pose estimate and set points, and it saves those into a file. And then I wrote a waypoint follower. So I'm going to close our viz. And let's just cancel that. So it's very convenient that I can just follow, tell it to follow this list. So let's find the follow. Might be in here. Hold on a sec. Yeah, so this script here can have it follow. So now let's direct our attention to the camera, and I'll start the challenge here. So this just sets it to go to the end of the room and come back. And by the way, this is so I forgot to mention, this is based on a Lino robot, or Lino Robot 2 hardware and Lino Robot 2 navigation GitHub. And I've modified it for Ackerman steering as well as GPS use, and improve the 9250 IMU driver code. So that I have my own fork. So let's go for it here.
We're looking at your desktop, Steve. You still want us to look at your desktop, Jim?
No, you can start looking at the camera now.
Okay, but you're sharing your desktop, so it overrides.
Oh, all right. Yeah, let me stop that and just a
Now we're
second.
looking at Truckosaurus.
I didn't know it did that. Yeah, hold. This is what it looks like inside. Oh, and my battery's low. It's always something.
Yeah.
Did we wait too long?
I had it on idle, ready to go, and
Yeah.
let's see. It all depends on whether. All depends on whether the system, the truck will, the truck that will actually go. I don't want to, yeah, deplete the battery too much because it's a lithium.
And that's an interesting question. When you monitor your battery voltage and when you shut it off.
I don't, this is all just a RC product. Yeah, I'm gonna bail. Sorry about that. It's out
It's
of
okay.
use. Thank you. But yeah,
I've seen the video. I know it works. Thank you very much, Jim DeNugio.
yeah. Thanks. Yeah, I'll be recording a video of this. Of this exact demo, and I'll post it later.
All right.
Right.
Jim DeNunzio, ladies and gentlemen, thank you
Yeah,
very much.
the battery just it's just an RC truck. When the battery goes low, you see a blinking red light, and that's it. You recharge the battery.
The lithiums don't have any more juice.
If
Say,
somebody
DJ
has a monitoring thing would be a nice improvement.
Yeah. Not
Dee Dee,
good
are
to-
you ready to go?
Not good to take.
Yeah,
them too
can you
long.
hear me okay?
Yeah, we can hear you. Okay, Ross Malunin, you're next. Dee Dee, go ahead.
Okay, so I have a couple updates. So here's my in-move, my silver in-move over here. And so what I'm doing is I'm working on a new face for it, a new head. The inventor of the in-move, he put up a new head, so it can be like a Sophia, which it has a silicone face, so it can show expressions, move the eyebrows, move the cheeks and everything like that. So it's the start
that
of a
won't
new.
be creepy. That won't be creepy at all.
Yeah, for sure. So we're upping up the scare factor here.
So what exactly are they making the faces out of now? They will be?
A silicone. So I have bottles of silicone.
Yeah,
and
I don't think I've seen that out there yet. Anybody doing that yet?
Yeah. So I noticed the InMove webpage had been updated, and it looks a lot like the Sophia kind of face there, or some of the other ones. So it's great to see an open source version. And it has the files that you can print the molds of, and then you put the silicone in the mold. So I'm looking forward to getting to that. Maybe after I present, I'll put the link in the chat. Okay.
Does the mask become like one solid piece that you would slide over the whole head, or is it in multi? Really? Wow.
The whole face is a solid piece. And then it has all the different motors for the components under the face to manipulate the silicone that's sitting on top. So work in progress. I'll put the link in the chat after I present. Okay. If there's no other questions, my project for our open source was to update my dancing dolls. Before, this one the blue one used to do all the work. The system is a Raspberry Pi. It's doing the videos, and it's sending out the robots themselves have an Arduino, the 2 DC motors with a caster in the back. And then it has an IMU, and of course the H bridge. So one of the things I did was I actually tapped into the IMU, the compass. So if it goes off course, it finds its way back home. So I worked on the math for that, for the IMU. And then of course it's coordinating with the programming I had before with the videos. And now I have 2 of the robots dancing. So
what do you call this again? You call this dancing dolls?
Yes, dancing doll twins. So yeah, I brought it to open source and we had a great time, and I brought it together with the a welcome bot. I think that's over there. I was waving to a whole bunch of people. Oh, and a welcome bot. Those two in the corner too. So, and my daughter also wants to say hi. She also
Welcome
helped me out.
at the ArmBot Phase 1 challenge. Hey there, how you doing?
So yeah, that's what we did at Open Sauce. Are there any other questions?
Very good, Dee Dee. Thank you very much.
How is
I love the robots. They're awesome.
Open Sauce? Is Open Sauce really an awesome show these days?
I loved it. Apparently it was 3 or 4 times as big as before. And it really felt like Maker Faire, but there was a lot more electronics, robot focus type of thing, less crafty. Also my kids liked it for different reasons. Like my daughter liked the whole creator thing. And the nice thing is this year there was actually like BattleBots and famous people in the bolts front, so you could talk to the people from BattleBots, and they had a whole state, multiple talks there too. So the energy of the place was a lot more like not kids, but and there was a lot of college students represented. I guess just the specific, and a lot of people there for the creators too. So it was good. Every year, right? Every year now. Well, this is the second so far, and they're already selling tickets for next year. The ticket prices were quite high. So for me, when I looked at the ticket prices, I said the only way I'm going is if I'm presenting, because I just can't imagine spending that kind of money for 3 people.
I can't imagine going without participating.
Okay, well, that's another way of saying it.
All right, thank you very much, Dee Dee. Those are wonderful robots. Hey, Ross, are you ready to go?
Yep, sure am.
Ross Lunan from Canada.
I'm sharing the screen now. Let's see, let's pick the right ones. So I joined the HBRC in 2011, bought a TurtleBot, got my feet wet when the meeting at Google, and move ahead a bit, and here we are with my TurtleBot that's now part of a project called the MuckBot, and so I'm going to do a run what you brung tonight. If the thing opens up, there we are. Okay, so ladies and gentlemen, Sheltron.
Sheltron.
Compliments of AI. So what you're looking at is a Create base that's now 12 years old, and it's probably on its third or fourth battery. Many of you will recognize the circles here. I've taken out one of the circles, and now of course use a Raspberry Pi equipped with Ubuntu 22.04. There we are, coming in for its close-up. And I've cloned this middle part here from a TurtleBot 4, which holds the RP LiDAR, OAK-D camera in the above that, and the little itty bitty MPU 9250 right up at the top of that stick. So it uses, as Jim mentioned, I'm using the Lino robot. Oops. Do a little dance here. I'm using the Lino robot repositories as a template to incorporate all the code that's necessary to get this thing running. So as you can see so far, the teleoperate works. That's a good start. I have a URDF all made up for it and the transfer frames, all in a great big file that will lead me on to the next stage, which is to actually build the code to do static transforms, and then onto the nav2 from the Mashinsky warehouse, their factory and development place. And this, as I mentioned before, as Camp may mention himself, my contribution is this will be described on how to build it in some part of his mock book.
Our book.
Yeah,
We're the mockers.
whatever.
All right.
So there
Ross
we are.
Lewin, ladies and gentlemen, with the mock turtle bot. Thank you very much.
Coming in for a bow. I'm surprised the damn thing still works. There we go, before the batteries die. Anyway, thank you all very much. It's just always great to do this sort of thing for this.
Sheltron from Canada.
Right.
Thank you, Ross. All right. Jimmy, are you ready?
Yep, I'll be fine. I'm ready to go.
Where you at, Jimmy?
I'm in Canberra in Australia.
Somebody down there. What time is it in Australia?
This is 26 minutes past 1 in the afternoon.
Okay. All right. We are international.
Big cold here this morning, but it's warming up now. Okay, so what I've got just my little project that I'll show to you. My technology is not great, so I'll have to use my little webcam to show you what I got around the room. You can see down there, there's a half-built robot that I call him Patch. He's just a bit of plywood with some motors and a Raspberry Pi and an Arduino driving him. He's going to be attached to, on that mast there's going to be a camera. I have an Oak D light that I'm trying to get working with facial recognition into ROS at present, and that's where I'm at right now. I have another robot around the corner there. That's an old, now that must be about 4 or 5 years old now. And also I have another toy robot, which is down the bottom here. If I can show it to you, where is he? There he is there. That's a toy that my son bought me, that I call a spider. I call him Spot, because in Australia here, we have a famous spider called a redback. And so he's kind of named after them. Okay, so what I'm trying to do with these 3 robots is I want to get them to be integrated together using ROS. And the plan is that I'll get facial recognition working on Patch with my Oak D camera, and that's Patch at the back there. And he'll drive around the house. I also have a LiDAR that I'll put on him, and I'm really impressed with the way you guys do the SLAM works. I want to get into that too, but that's not on him yet. So that's where I'm going. I want him to drive around the house to do facial recognition. I want to be able to say to Patch, go and look in the bedroom to see if Jane's my wife, to see if Jane is there, and then I want him to come back and tell me if she is. That's where I'm going. That's the ambition.
So it's Patch, Spot, and who else?
And well, I call the little now I call him Ami, because he's French and he was my friend. I call him Ami when I first got him because he was my friend. Hey,
AMI,
Ami, because yeah, he's originally a French one.
So what? Ami's back is behind you there.
Well, no, this one here is what I call Patch. He was meant to be a dog to start off with, but with an earlier robot I was doing facial recognition, but he was on the floor. He's just a small little robot. He was on the floor, and his facial recognition wouldn't work on the floor, so I had to keep him on a table all the time, and he couldn't move around. So I thought when I built Patch, bigger wheels, drive around the carpet, no problem, but the camera would have to be high up in the air. So you can do facial recognition. So well, I call him a giraffe.
That's a righteous floor bot. Floor bot's a robot that's too big for the table.
Oh yeah. Well, there you go. That's what it is. Yeah. So right now I'm in the depths of facial recognition with Depth AI on my OAK-D Lite, and then integrating that into ROS, which is where I am right now.
Very good.
So I thought I'd show you something rather than just talk about it. So what I'd like to do is to share my screen, but the problem I have is my old computer here bails. It often bails when the screen is sharing. So if the screen, if it crashes, consider that to be the end of my presentation.
Go for it, Jimmy.
So I'll try and share the screen and we'll see how we go. If I don't, thanks a lot. Okay, can you see my screen?
Yes.
Oh yeah, you're still there. So what I have now is I have Patch running on the left-hand side over here, and this is Spot running on the right-hand side. This is they're waiting for the wake word. I used to use I can't remember what it's gone out of my head, but I use Open Wake Word now because Pico Voice. I used to use Pico Voice all the time, but for some reason they stopped my license. They just cut it off. One day it wouldn't work anymore. And so I got fed up with that. So I now go to Open Wake Word, which isn't as good. And I'll show you with Patch. He sometimes doesn't wake up. So if I say, hey, Patch. So he's woken up there, and then I can ask him. So he's listening to me now. Patch talks to ChatGPT, and then we'll get a reply. So this is the reply coming back from ChatGPT. I've got him so that we have like a conversation, so that the idea is I don't have to say hey Patch all the time. So I have to be quiet if I want him to. So a problem I have that I'd like help with is that while I can do my speech to text, okay, I'm using VOS for that. What comes back, because I'm streaming it, the sentences are broken up and it's not very good. Yeah, that's the problem I have. I should reach out to you guys more about.
Post to the mailing list.
Yes, I will. I'm only just new to the club and I've been a bit shy about doing that.
Yeah, we've been through, a lot of us have been through these problems, or these issues.
Yeah, I'm sure you. Yeah, and I feel very much like I'm just reinventing the wheel here. So if I can stop Patch, I'll just close him there, and then and then if I wake up Spot, hey Spot. So this is Spot. Spot's running on Claude. I don't like Claude so much as ChatGPT. I find it, I don't know, he's a bit expensive, and then he doesn't get very good replies to what what I'm getting. I'm also, what I want to do is to get the AI to control the robot. So you see, this is the reply coming back from Claude. Do you see how it comes back in these little chunks there, which is a problem? I'm trying to get the AI to control the robot. So I've got Patch has an MPU on him, and what I can do is I give Patch an oral command, and then he will go to polar coordinates, so that there's if I say go to position 30 degrees to the, so this is Spot talking to me. Anyway, so I could, like everybody else, I can rabbit on for ages about my problems, but I
Thank
could,
you for sharing, Jimmy.
Yeah,
And
I'd like to.
We look forward to seeing your progress in the September meeting. We do this every
couple
months.
I'll share in September, but where I'm up, I'm not sure how. Maybe I'll have vision going by then.
Without a challenge, nothing happens. Without a deadline, nothing happens. Who else has a show and tell this evening? Thank you very much, Jimmy from Australia.
Yay!
Thank you.
Hey.
Thank you for being on our time zone.
And Patch, Spot, and me. Who else has a demo this evening? Anybody else? All right, I got one thing to show. Let me share my screen here. and that's this. I I'm hosting a homebrew robotics club in Tallahassee now. And we meet at a maker space called Making Awesome. And here's me mapping and navigating. Can you see my screen okay? So here I mapped out the Making Awesome maker space, and that's Smarty, the smart table. Navigating around. So let's see. So here's here I've actually got him geared up outside. It's a live demo. I have to rescue him. Am I still sharing my screen? Could you see it?
Yep.
Yes?
Yep.
Yes, you are. All right. Let me get the video going here. And I shall attempt to navigate to the other side of the apartment here. Here comes the robot down the hallway, nothing up my sleeve. That's Smarty 2. It's basically a Create 3 base with a DL06 LiDAR and a Logitech C270 camera. So he's navigated to the other end of the hallway there. It is relocalizing. Let's go to the other end of the hallway, or let's go all the way to the kitchen. Getting a little delocalized there. I'm going to help him out. If I spin him around, he should relocalize. Let's set him a new pose right up here. My demo's going terribly wrong now. I'm going to spin him around, see if I can get him localized. Okay, and one final trip, we'll navigate to the lounge here. Here you see the path planning lines. You see the robot coming down the hallway. And here he comes into the lounge. Oh, don't be shy now. Well, he's getting worse. Let's reset the pose. And come into the lounge. There's the robot. And that's it. Thank you very much. Is there any other demos this evening? Anything else anybody wants to show robot wise? Well, I hope you were entertained. I'd like to thank everybody that came out, and I'd especially like to thank everybody that participated. Our stock in trade is functioning robots, but works in progress are good for partial credit. Once again, I hope everybody had a good time, and I'll make a motion that we close this meeting. Do I have a second?
Second.
All in favor, say aye.
Aye.
Aye. Those opposed, say no. Ayes have it. Meeting adjourned. See you next month.
Camp, we're not meeting tomorrow night, right?
No
Not
big
meeting
thing
tomorrow night.
evening. Right, Thomas?
Big Sig is not meeting tomorrow night.